ඔබගේ මයි පියාඹන්න නැහැ බාධා දකින්න හීන දකින්න ආයෙත් නැහැ බාධා ගමේ නගරයේ කන්දේ තැනිතලාවේ
හීන දකින්න ආයෙත් නැහැ බාධා
අඳුරේ
Sysygy online mahakethara.
So good morning guys, hope you can hear me clearly and see me clearly. So today's main criteria is like to cover all the measuring instruments related practical. So I mean this thing is not going to be a boring session, okay? That means I'm not gonna dig deep into theory. So what we are gonna do is there are some like fundamental issue here, like you guys, we don't know whether you would go to school on time, go to the practicals on time. But the thing is, in A-levels, they expect you to have a good idea about practicals. They expect you to go there and do practicals. So like that, they expect you to do that. So they do the paper that way. They create the paper that way. So the problem is, we don't know what happens from your side, whether you go to the school or whether you write private, whether you are going to whether on the lab day, whether you miss it or not, you know, right? You guys have a lot of work. So, so from our side, what we are going to do is for all the practicals, okay? For all the practicals in the syllabus, we are going to do these kind of separate practical sessions and practical workshops where you can clearly learn like how a practical is actually done, okay? So this is an English medium session, okay? මම ඒ වගේම කියන සිංහල මීඩියම් ළමයින්ට අපි තව සෙෂන් එකක් කරනවා බොහෝ දුරට ලබන බ්‍රහස්පතින්දා වෙද්දී අපි ඒක ගැන ගෲප් වල හැමතැනම දැනුම් දෙන්නම් සිංහල මීඩියම් ළමයින්ට තව සෙෂන් එකක් එනවා අද සිංහල මීඩියම් ළමයින්ගේ සෙෂන් එක නෙමෙයි ඉංග්‍රීසි මීඩියම් ළමයින්ගේ සෙෂන් එක. So today is the English medium session and the Sinhala medium session will also happen in the next week. So we'll inform about that in the group too. So today's main target is to go through until now, we are going to do this for all the practicals in the syllabus, okay? We are going to do this for all the practicals in the syllabus, but for now the target is to, since we have finished measuring instruments lesson and we are starting the vectors lesson next week, okay? Since we are starting the vectors lesson next week, before going there, okay? Before going there, we should have a good clarity about all the measuring instruments, okay? We should have a good understanding about all the measurements, how they are done, how they are taken and everything, okay? So giving a good clarity about that is our main target today. So my plan is, there will be a series of measuring instruments, okay? So I'll most probably start with the the vernier caliper, okay? I'll start with the vernier caliper and move to the traveling microscope because they are like instruments related with the vernier principle, okay? Instruments related with the vernier principle. Then I'll be moving to the micrometer screw gauge, okay? Then we'll be moving to the micrometer screw gauge and the spherometer, okay? And we'll exactly show you how a practical is done. And again, like one of the main issues in the class students asked was how do we see things through this, okay? How do we see things through this? So there's no point of me doing the practical like this, right? Because then you won't have a clarity about how you see things. So I'm gonna somehow use the cameras and show you how would you see things here, okay? How would you see things here when you're looking from this? How would you see things here? We are gonna show things how. So it would be like most probably like you are doing a practical, okay? Clear? Most probably it would look like you are doing the practical. You are doing the entire practical. So that is the target. I know. Some students asked about the vernier principle, how it's taken, after that, how the least count is taken. So these theory parts I'm going to keep towards the end, because we all know you guys never stay in a session until end, right? So I have to finish the important parts first. So I'm going to go through, I'm not going to start with the vernier principle. Okay, this is the vernier principle. I'm not going to do like that. What I'm going to do is, I'm going to show you, okay, this is a vernier caliper. This is how we get the measurement. Then I'll show you how to do the practical, not the vernier principle. I'll show you how to do the practical. Then I'll move to the traveling microscope as the second instrument quickly, because that is the most important one here. Because other instruments you can have a clarity without just looking from a distance, but not the traveling microscope, okay? So next I'm going to move to the traveling microscope. I'm not going to talk about vernier principle or anything like that. I'm going to show you how to use this. How would you see things through this? You know that from the traveling microscope. And don't worry, if you haven't done traveling microscope, still it's going to be okay. So you can stay in the session, no worries, okay? So, so how things get inverted and everything, okay? Like that, I'm going to finish doing the practicals first, okay? I'm going to first go through the practicals and finish doing the practicals first. Then only I'll be moving to the other, then after finishing the practicals, I'll go through, okay, vernier principle. This is how the vernier principle works, okay? This is how the vernier principle works. This is how, this is why, how we take the least count, everything like that, okay? Everything like that will like explain towards the end of the session. So for the people who have a good clarity about that area, about the theory area, I mean, they can feel free to leave. But I mean, try to stay in a session until end, okay? Why? Because I mean, that is the, like, I mean, if you build this ability, I mean, if you lose that ability to stay in a session for a longer period of time, maybe 2 hours, 3 hours at least, I mean, towards time, you're going to grow that ability, okay? So that means you're going to, I mean, you're not going to stay in any session until end. You can't focus on anything. So you grow that habit. So whatever the session we do, you leave in the middle. So don't start that, okay? Don't start that. Just if you come to a session, try to stay until the end, okay? Try to stay until then, because consistency matters, okay? So let's start with the vernier caliper. I know the most important instrument is the micrometer. The most important one is the traveling microscope, but let's first go through the vernier principle a bit, okay? Let's first go through the vernier principle a bit. Then move to vernier caliper, so that you would have a good clarity about the instrument. Then let's move to, like, when you have a good clarity about the vernier principle, then let's move to the traveling microscope, okay? So starting with the vernier caliper, I decided to go first with a simulation, okay? The reason is, I mean, it's easy to explain things here, okay? It's easy to explain things here. So this is a vernier caliper, okay? This is a simulation of a vernier caliper, okay? This is going to be a simulation of a vernier caliper, okay? So what I'm going to teach you here is how to take a measurement, not how the vernier principle works, just how to use this instrument, okay? That's all I'm going to teach at this moment. Towards the end of today's session, I'm going to do the theory parts again. What is the vernier principle, how that works, what is the micrometer principle, how that works, everything will be taught towards the end. So at the moment, what I'm going to do is, knowing the least count, how would you take a measurement, okay? At the moment, what I'm going to teach is, knowing the least count, how would you take the measurement, okay? That is the target, okay? So the least count of this instrument is 0.1 millimeters, okay? When actually using the measuring instrument, you don't have to worry about the least count. Why? It comes printed on the instruments, okay? So when we do the actual practical at the lab, you don't have to do that step of finding the least count, okay? Clear? When we are actually doing the practical at the lab, you don't have to go through that step of finding the least count. Because I mean, you will be like, you don't have to go through that, because it comes printed on the instrument, okay? It comes printed on the instrument. So you don't have to like go through all the mathematical parts, okay? You don't have to go through all the mathematical parts. What you have to do is just knowing the least count, get the reading, okay? So we are going to first do the practical like that, because then we can finish the important parts first. So this is a vernier caliper, okay? This is a vernier caliper. and this is how it works. This is how it works. Okay, how the instrument is used, I'll go to the actual instrument and explain, but at the moment, let's learn how to take a measurement. So this we call the main scale, and put on the chat, okay, whether in the class you understood vernier principle or not. Put on the chat, then I can see that, and like arrange my session according to that, okay. So this is the vernier caliper, okay. This is the vernier caliper. Now, see, there's a main scale here, okay. There's a main scale here, and there's a moving vernier scale here, okay. There's a moving vernier scale here. So how do we get a measurement? Ideally, okay, ideally the two jaws stay touched with each other, okay. When two jaws stay touched with each other, it becomes 0, 0, okay. It becomes 0, 0, clear? When the two jaws touch each other, it becomes 0, 0 from a working instrument, okay. Then, and even the zero errors kind of stuff I'm going to do at the end, because they are more theoretical. First, we are going to focus on how to use the instrument, how to do things, okay. That is the first thing, okay. So all how to do the practical kind of stuff will be in the first part. Towards the end, zero error, how the zero error is taken, how zero errors are corrected, everything like that would be done at the towards the end of the session, okay. So in this case, like how do we use this instrument? Assume that you have something like this, okay. Assume that you have something like this. Least count of this instrument is 0.1 millimeters, okay. Least count of this instrument is 0.1 millimeters. Now as you see, okay, as you see here, you have 0 to the least count of this is 1 millimeter. 0, 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, 5 millimeter. That's why it's written 0.5 centimeters here. 6 millimeter, 7 millimeter, 8 millimeter, 9 millimeter, 10 millimeters. So 10 millimeters written as 1 centimeter here. So what you do is you get the last guy before the vernier 0. So in this case, who's the last guy before the vernier 0? Who's the last guy before the vernier 0? This one, clear? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See, just before the vernier 0, you have the 11th millimeter. Just before the vernier 0, you have the 11th millimeter, clear? You have the 11th millimeter. So, how would we get the reading is, okay? How would we get the reading is, you first write that one, 11th millimeter, okay? You first write that one, 11th millimeter. So, we first write 11th millimeter, okay? We first write 11th millimeter plus, then we get the least count. Then we get the least count. As I said, in that instrument, least count is 0.1 millimeters. We don't have to worry about the least count. Why? It comes printed on the instrument when you are doing the practical at the lab, okay? Clear? Then what you have to do is, you have to find a specific number. You have to find a specific number where it creates a straight line with the main scale. You have to find a specific number where it creates a straight line, okay? Where it creates a straight line with the main scale. Like what? In this example, we are going to go through the vernier readings. 0. Now you have to look at the vernier scale. 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. So, see the fourth vernier line. Fourth vernier line creates a straight line, right? 0, 1, 2, 3, 4. The fourth vernier line creates a straight line, okay? So, what you do is you write 4 here. You write 4 here, clear? Fourth vernier line creates a straight line, so you write 4 here. Okay, so this is going to be the reading. 11 millimeters, 11 millimeters plus, here you get 0.4 millimeters, okay? 11 millimeters plus 0.4 millimeters, which means 11.4 millimeters, okay? 11.4 millimeters, okay? We are gonna get 11.4 millimeters. That's how it works. Clear? Okay. So I'm not gonna do a lot of examples on how to get readings and all, because that I think in all the classes you have learned properly. So what I'm gonna do is I'm gonna move fast through the these kind of stuff and explain the practicals as fast as possible. Then towards the end we'll do some examples. I'll explain again how the vernier readings works, how the vernier caliper, the vernier principle was derived. I'll explain those parts towards the end, because I mean most of the guys, I think you have a good clarity about that, okay? So let's keep that to the end, so it's not mandatory for everyone, okay? So that is the idea. So again, if I show you another measurement, here, see, go through the main scale, find the guy just before the main scale, just before the vernier 0. So this is the vernier scale, this is vernier 0. So you have, see, 5, 10, 15, 20, 25. 25th, you have the 25th main scale division. 25th main scale division here you have just before the vernier 0, right? Clear? You have 25th main scale division before the vernier 0. So it's going to be first 25 millimeters. Then you have to find who creates a straight line in the vernier scale. 0, 1, 2, 3, 4, 5, 6, 7. Can you see the 7th one? Can you see the 7th one creates a straight line, right? See, the 7th one, the 7th guy creates a perfect straight line. See, 7th guy creates a perfect straight line. Clear? So the final idea is it's 25 just before the vernier 0, it's 25. Just before the vernier 0, it's 25, okay? And you have the 7th guy creating a straight line. So let's put that to the equation. 25 millimeters, 25 millimeters, okay? 25 millimeters plus the least count, 0.1 millimeters into who created the straight line? As I remember, the 7th line created the straight line, right? Clear? So you get 25 millimeter plus 0.7 millimeters, which means 25.7 millimeters. Okay, so there are two main instruments that use this vernier principle in our syllabus. One is the traveling microscope, okay? One is the traveling microscope, okay? And the other one is vernier caliper. The easier one is vernier caliper, so let's start with that. So there are external jaws, okay? There are external jaws, okay? External jaws, internal jaws, external jaws, internal jaws, and a depth probe, in a vernier caliper. So with this, can you try this? Okay. So in this case, so as you see, with the external jaws, with the external jaws, with the internal jaws, with the internal jaws, with the external jaws, this vernier scale moves, okay? See, this vernier scale moves, clear? Vernier scale moves with the external jaws, with the internal jaws, and with the depth probe, clear? With the depth probe. So whatever the thing you measure from the depth probe, whatever the thing you measure from the internal jaws, whatever the thing you measure from the external jaws, okay? Whatever the thing you measure from the external jaws, you can read using this main scale and the vernier scale. Okay, you can use this main scale and the vernier scale. So as I mentioned, see the least count comes printed. Okay, least count comes printed here. Okay, clear? That is the thing. Okay, so when we are doing the, see, even in this traveling microscope, see, least count comes printed. See, 0.01 millimeters. See, in any instrument, least count comes printed. Okay, so we don't have to worry about that when we are doing the practical, but in theory, yes, we have to learn that. Okay, so doing practicals are very simple. When you need to measure something externally, what you do is you place this by around external jaws. Clear? You place it from external jaws like this. Clear? You place it from external jaws like this. Clear? You properly fix it, and when it is confirmed, you can use this nut here. See, this guy, this nut here, you can use this nut here. So when you connect that, it stops moving. When you connect this properly, it stops moving. Okay, then you can peacefully get this. Okay, you connect that nut, then you can peacefully get the reading. Okay, you can peacefully get the reading. So how to get the reading, let's again see towards the end of the session. All the theory related stuff I'm going to do at the end. So you have the main scale, then you have the vernier scale. Clear? You have the main scale here, and at the same time you have the vernier scale moving here. Clear? Main scale and the vernier scale. Using them, you can get the reading. Again, you have to lose this nut. Clear? Then only you can move this stuff. Then what you're going to do is, when you need to measure something internally, you're going to use internal jaws. Like this. Clear? Measure the internal diameter of the tube. You're going to use internal jaws. Internal jaws like this. Clear? So when you use internal jaws like this, again you connect the nut, get the reading. Okay, get the reading from the main scale and from the vernier scale. Okay, then when you need to measure a depth, you place it at the end like this and move it down until it hit the bottom. You move this down, okay, until it hit the bottom. Clear? Like this until it hit the bottom. Clear? You are going to move the instrument until it hit the bottom. Then what you are going to do is, you are going to again get the reading from the main scale and from the vernier scale. See, the vernier scale moves with the depth probe. See, vernier scale moves with the depth probe. See, it moves with the depth probe. So when it comes to 0, see, when the reading is 0 here, it reaches 0. When you move it, the vernier scale moves along the main scale. See, when you move it, the vernier scale moves along the main scale. Okay, so that's how we get a reading using the vernier caliper. Okay, that's how we get a reading using the vernier caliper. Okay, so there are this is a bit kind of engineering vernier caliper. There are vernier calipers like this, plastic ones used for very simple stuff. Okay, even in tattoo shops you can see, even in salons you can sometimes see vernier calipers used for some specific tasks. Okay, this is a most of a engineering vernier caliper, very precise, very low errors, and the least count is 0.05. Least count of this is 0.05 millimeters. Clear? So that's the idea about the vernier caliper. So we are going to move back to the vernier caliper towards the end of the session. Again, get some readings, do some questions like that. Let's do some stuff like that. But first of all, let's finish the proper measuring instruments. Okay, first let's finish the proper set of measuring instruments. So take this, the traveling microscope. Again, use as a vernier principle. That means as you see, there are vernier scales like this. Okay, there are vernier scales like this. See, a main scale and a vernier scale. You have a main scale and a vernier scale. This vernier scale moves with this instrument. Okay, this main scale moves with this. See, vernier scale moves with this instrument. Okay, clear? Main scale moves with this, vernier scale moves with this instrument. So I'll be doing this again and again. That means some stuff I have to show first, some stuff I have to show later. So it's going to be a kind of a bit longer practical here. Okay, but the things is how do we measure things using this traveling microscope is whatever you need to measure, you focus from this microscope. See, you can move the microscope like this. Okay, you can move the microscope like this. Okay, based on your requirement. Okay, so whatever you need to measure. Okay, if you need to measure something from forward, you place it in front of this. Okay, you place it in front of this and you first focus. Okay, you first focus. Clear? How are we going to focus? We are gonna look through this. This end we call the eyepiece. This end we call the objective lens. We are going to look through this, focus on whatever we need to measure, properly focus on whatever we need to measure. Okay, properly focus on whatever we need to measure. Then move this. Okay, then move this with that measurement. Then move this with that measurement. So when moving this, there are two ways you can move things. One is you are going to lose this nut. You are going to lose this nut. You are going to first lose this nut and you are going to move it freely. Okay, you are going to move it freely. So when you move it freely, you can see with the main scale, the vernier scale moves. Okay, with the main scale, the vernier scale moves. Okay, vernier scale moves with the main scale. Okay, and assume like we use this to measure very small measurements like 0.01 millimeters. Can you move this by 0.01 millimeters? Can you move this by 0.01 millimeters? No. Okay, so if a such requirement occurs, if you need to move this by very small measurements, what you are going to do is you are going to connect this nut. Okay, you are going to connect this nut properly. Connect that. You are going to connect that nut. When you connect that nut, this guy gets connected to this lane. This guy gets connected to this lane. Now you can rotate this. What is this? This is the fine adjustment screw. This we call the fine adjustment screw. Now you can rotate it using the fine adjustment screw. So as you see, it moves, but it moves really slow. Okay, it moves, but it moves really slow. Clear? Okay, see, it moves really slow in this case. I'm rotating this really fast, but it moves by 0.01 millimeters of sizes. Okay, clear? So when doing the practical, one of the main issues you have is how do we see things here? So I'll first try to show that. Okay, how do we see things here? Yes, there are a lot of stuff to be done before. We have to level the instrument. All the other stuff I'll explain towards the end. Okay, all the other stuff I'll explain towards the end. We'll first see how we see things. Okay, that is the most important part. Mirror. Okay, so I'm going to take this piece of paper. Okay, I'm going to take this small piece of paper. Clear? And let's write something on that. Let's write something on that. Let's write 57. Let's write 50. Let's write 57. Okay. I'm gonna write something really small, okay? Okay, something really small. And let's draw a circle too. Let's draw a circle too. Okay. So now I'm gonna place it on this table, okay? I'm gonna place it on this table like this. Then I'm gonna focus it like this. I'm gonna focus it like this. Okay, I'm gonna focus the objective lens like this. Then I have to definitely look through this. I definitely have to look through this and make sure I can see this. Okay, I have to place this very carefully and make sure that I can see it. Okay, I have to make sure that I can see it. Now, okay, so focusing on this is not a very easy task. Okay, why? It's like 10 times magnified. Okay, it's like 10 times magnified. So now I can roughly see that. Okay, now I can roughly see that through this. Okay, so okay, now I have roughly focused this. Okay, okay, so if I try to show you this, okay, give me a second. Okay, so what I'm gonna do is I'm gonna show you. Okay, I'm gonna show you how things are seen through this. Okay, okay, so let's use the phone. Okay, there's no other solution for this. Let's use the phone. See, this is how you're gonna see things. Okay, this is how you're gonna see things. Clear? Hope you can see this roughly. This is how you're gonna see things. I think it's better if I can draw this on a white piece of paper, right? See, when you look through this instrument, okay, when you look through this instrument, when you keep your eye on this instrument, this is how you're gonna see things. Clear? This is how you would see things. Clear? Okay, so this is the most important thing, right? See, as a person, so this is how we work as a person. Okay, now as a person, when I look at the instrument, this is how I'm gonna see this. I'm gonna see the vernier scale like this. I'm gonna see the vernier scale like this. I'm gonna see the instrument like this. This is the first person view. This is how I'm gonna see whatever I'm measuring. Okay, this is how I see whatever I'm measuring. See the crosswires? Clear? Can you see the crosswires? There are two crosswires here. Okay, there are two crosswires here. Clear? We use those crosswires to move this. Okay, I mean to properly align it. Okay, and you see, and can you see 57 is inverted and upside down. Okay, when you look through this, 57 is inverted and upside down. And as you saw, I wrote something really small and it's way magnified. Okay, It's way magnified here. So when I, as a person, when I move this, what I'm gonna see is, I'm gonna see that it is moving. See, the crosswires are moving. See, I'm gonna see the crosswires are moving. Can you see? See, we can see the crosswires are moving. Clear? That happens when I rotate this. Okay, when I rotate this. Clear? Then like another thing, as you see it's not very nicely aligned. Okay, it's not very nicely aligned, so it's good if I can rotate this piece and make the crosswires properly. See, I can rotate things. Okay, I can rotate this whenever required and make sure that crosswires vertical and horizontal are vertical and horizontal properly. Okay, see, clear? Before doing measurements, we have to make sure that, see, we have to make sure that crosswires are properly vertical and horizontal. Clear? Okay, then again what we do is we place the object like this. Okay, I'll repeat, place whatever you need to measure on the table, and make sure that you move the instrument until you can see it very clearly. Okay, have to make sure that you move the instrument until you can see it very clearly. Okay, so one like more important stuff would be like, don't use a white background when you're like, that's why I used a yellow paper. Don't use a white background. I mean, since the table is a white background, okay, don't use anything with a white color here. Why? I mean, yes, whatever you have to measure, if it is white, then there's nothing you could do. But I mean, the problem is if it is white, you are not going to be able to find it. Okay, because I mean, when it is zoomed, it's really fine where you have this. Okay, so these are the main practical issues that you are going to face. Okay, and these are the issues that they are going to ask, because a student who went to the lab and actually done the practical would understand that since this is zoomed a lot, it's really difficult where the object that you need to measure. Okay, it's really difficult to find the location of it. Okay, that's why I slowly use my finger, move it here and there like that, then try to figure out where can I find the paper. Okay, that is the reason. That's why it's very difficult to move it like this. Okay, especially using fingers. Since I'm using my fingers to move this, it's really difficult to focus on whatever you need to focus. Okay, and the next thing, assume you are measuring something. Let's assume that you are measuring something. Okay, let's assume that you have to measure the diameter of something. So assume that you have to measure the diameter of this circle. Okay, let's assume that you have to measure the diameter of this circle. So what I'm going to do is I'm going to place the crosswires. I'm going to place the crosswires like this. How? I'm going to place the crosswires like, if this is the, let's assume that this is a tube. Okay, let's assume that this is a tube. I need to measure the external diameter of the tube. That means this length. If I need to measure the external diameter of the tube, that means this length. What I'm going to do is I'm going to first place the crosswires here. Clear? I'm going to place the crosswires here. Like this. I'm going to place the crosswires here. I'm going to focus it here. Okay, I'm going to focus it here. Then what I'm going to do is I'm going to see, as you see, I'm going to place it here. Now what I'm going to do is I'm going to get this horizontal and vertical reading. Okay, I'm going to get this main scale and vernier scale reading. Okay, I'm going to read this main scale and vernier scale reading. Clear? This is my main scale, this is my vernier scale. So just the same mechanism. Last guy on the main scale plus the least count into the one who creates a straight line, okay? The one who creates a straight line. Clear? I'll show the diagrams and then you would get a very good clarity. So that's how we are going to do things, okay? So we are going to get the reading here, clear? We are going to get the reading from the main scale and the vernier scale, clear? Then what we are going to do is, we are going to again look back. We are going to again look back. And what we are going to do is, we are going to move this horizontal fine adjustment screw until it moves to the other end. We are going to move that fine adjustment screw. Now see, the setup is moving, okay? The setup is moving. I'm going to rotate that fine adjustment screw. I'm going to rotate this fine adjustment screw until it moves to the other end. Clear? Exact other end. See? Until it moves to the exact other end. Clear? Got the idea? So in that case, from this, what I'm going to do is, I'm going to move here. From there, I'm going to move here. Clear? From there, I'm going to move this end. Clear? I'm going to move this end. Clear? And what I'm going to do is, I'm going to get the main scale and vernier scale reading in that scenario too. Okay? I'm going to get the, in that case also, what I'm going to do is, I'm going to get the main scale reading and the vernier scale reading in that scenario too. Okay? Clear? I'll be getting the main scale reading and the vernier scale reading. So I would have two readings. I'm going to have two readings. Some kind of a reading here, R1. Some kind of reading here, R2. Then actually, the diameter of the tube, the diameter of whatever the circle I need to measure, this diameter of the tube, I can get by R2 minus R1, right? Or R1 minus R2. R2 minus R1 or R1 minus R2. We use this symbol to show the magnitude. This symbol means magnitude of R2 and minus R1. Clear? We are going to get the magnitude. Okay. So that's how we would measure things externally. So as you see, the cross wires moves from this end to this end. Okay. Cross wires move from this end to this end. Clear? And at the same time, when the cross wires are moving, the vernier scale will be moving. So as a result, if my cross wires move 1 millimeter, the vernier scale will move 1 millimeter. So whatever the two readings I take will show a difference of 1 millimeter perfectly. Clear? Will show a difference of 1 millimeter perfectly. Clear? That's how the things are done using the traveling microscope. And as you see, my 57 that I wrote, okay, the 57 that I wrote, okay, how it appears to be. The 57, see, this is 57. This is how you see it, okay? I don't know whether, yeah, this is how you see it from your eyes, okay? This is how you see it from your eyes. This is the 57 I wrote, okay? This is the 57. This is the 57 I wrote. But how you would see things through this is, now I can't see 57, so I have to move this. How I'm going to move it is using the fine adjustment screw. See, it's inverted and upside down, okay? It's inverted and upside down. Clear? It's inverted and upside down. Let's take a photo of it. Clear? So, how are we going to see things there? It is it's going to be inverted and upside down. Okay, clear? It's going to be inverted and upside down like this. Clear? That's how it happens. Okay, that's how it happens. So you have to be careful. Okay, why do you have to be careful? So like if you move if you look at something, you first have to properly focus and properly identify its alignment. Okay, because everything is shifted. Okay, everything is shifted. Okay, so when you are using this instrument, okay, what you have to do is you have to properly understand the alignment of the object. Why? I mean, if you need to like move from 5 to 7, okay, if you need to move from 5 to 7, okay, that means if you are moving the crosswires from 5 to 7, you actually move it physically. Okay, you actually move it physically. Clear? You actually move it physically. So physically when you look at the paper, if you see 5 on this side and 7 on this side, physically when you look at the paper, when you look at this piece of paper, if 5 is in this side and 7 is in this side, to move from 5 to 7, I have to move this in this direction. Okay, if physically 5 is in this side and 7 is in this side, to move from 5 to 7, I have to move it in this direction. Clear? In this direction, I have to move it in this direction. Okay, I have to move it in this direction. But I mean, you won't see that through the eyepiece. Why? Everything is inverted. So you have to do the movement physically. Okay, clear? If you keep looking at this, okay, now since things are inverted, you may think, okay, I have to go in this direction, but it's just an illusion. Okay, if you look from this and think, okay, I have to go from 5 to 7, but in that case 5 is in this side, and 7 is in this side, right? In that case 5 is in this side and 7 is in this side. You may think you have to go in this direction. You have to move the instrument in this direction. Okay, you may think that you have to move the instrument in this direction, but the actual thing is it's not the case. Although you see it like this, the actual object is here. So to go from 5 to 7, you have to move the instrument in this direction. Okay, clear? Looking at something complex, okay, you have to have that absolute clarity. Yes, to look at 57, it's not a big deal. You move in one direction, okay, I'm losing 5, so I'm going to move in opposite direction. So when looking at something simple, it's not going to be a big deal. But if you are like analyzing a complex structure, okay, if you're analyzing a complex structure, you have to have that absolute clarity that what you are seeing is an illusion. Okay, what you are seeing is an illusion. That means 5 and 7 is inverted. Okay, 5 and 7 is inverted. So if you look at the microscope and if you think, okay, to go from 5 to 7, I have to move the instrument in this direction, that's not the case. To go from 5 to 7, you have to move the instrument in this direction. So when moving the traveling microscope, using the fine adjustment screws and using the vertical adjustment screws and horizontal adjustment screws, you look at the actual object. Okay, you look at the actual object and move. Clear? Got the idea? Because it has to be done physically. Not based on what you see, because what you see is inverted and upside down. If you try to move it based on what you see, you are going to always go in the wrong direction. Okay, so you look at the piece of paper or whatever the object you have to look physically, then decide the movement. Okay, I have to go in this direction, I have to go in that direction. Clear? That clarity you should have. Okay, because I'm explaining this because these practicals should be done fast. Okay, you don't have like 5 hours to go around and look at the traveling microscope. It's going to be 1 or 2 periods at the school. So you have to have a very good clarity even though you do the practical. And at the same time, we know what happens when you go to school and do the practical, right? Only one guy do the practical, all the others are watching. So you have no absolute clarity. And I mean, we have 26 batch A-level students. have never seen through a traveling microscope, okay? That's why we decided to do this for your batch, okay? We have 26 A-level batch students who are going to A-level recently, okay? They have never seen, like, they have never looked through a traveling microscope, actually kept the eye on the eyepiece. So it's a problem, because I mean, you can't answer practicals, okay? You can't answer practicals without a very good clarity about how it's been used, okay? So do you understand things up to now? But that's not all, okay? That's not all. There's a lot of things we have to learn about this instrument. But I mean, do you understand that? Any questions put on the chat? Any questions put on the chat? So very important questions we have. Very important questions we have. Do you play Minecraft? Okay. So shows upside down. Yeah. Focus on career, not girls. I think it's not an advice for me, right? Any important questions, guys? That you see? What about 67? Any important questions, guys? Really, you're not gonna ask anything important? Oh, cool. Yeah. Not only the pendulum practicals, we are gonna do this for all the practicals. Okay, clear? We are gonna do this for all the practicals in the syllabus. Because I mean, for a very longer period of time, we expected you to go to the school and do the practicals, and eventually we figured out that you never do that. Okay, clearly, we figured out you never do that properly. Okay, so when the teacher asked to the class and ask you to go to the lab to do practicals, there are like 50 students, and at the lab there's only 15 students. That's what usually happens. So we know that like close to 35 students, like almost 70% of the students never see a practical. It's not a problem of the school or the school system or teachers. It's your problem. Okay, you run to the ground whenever they ask you to do the practical. So we can't expect things like that from you guys anymore. So we decided, okay, let's do it ourselves. Okay, at the end of the day, at least when you're at home, you can run to the ground. Okay. Yeah, we are gonna explain about how the vertical measurements are taken and everything. Cool. Let's move forward. So there's a lot more to learn here, okay? There's a lot more to learn here. That's not all. Why? It's not only about the horizontal scale, okay? It's not only about horizontal scale. You can measure things vertically. You can place this like this. Okay, you can place it like this. Okay, then move it like this until you can focus on it. Then move it like this until you can focus on it. Place something in front of it. Then not only the horizontal scale. Yes, you can move things horizontally like this using the horizontal fine adjustment screw. And if you need to move this fast, what you're going to do is you're going to release this nut. And you're going to freely move this, okay? You're going to freely move this. Clear? And at the same time, there's something you should see. There's a vertical measuring method too. Vertical measuring method means, see this? We can measure things vertically too, okay? We can measure things vertically too. Okay, the same way as we discussed, okay? There's a vertical main scale, vertical vernier scale. There's a vertical main scale and a vertical vernier scale, okay? So in that case, again you have a screw like this. You have a screw like this. You're going to release that screw. If you release that screw, you can freely move this up You can freely move this down. But your hand don't have a very precise movement. You can't move this by 0.1 millimeters, right? See, you can't move this by 0.1 millimeters. So what you're gonna do is, yeah, again gonna connect this nut here. Yeah, again gonna, am I rotating it in the wrong direction? Yeah, gonna again connect this nut properly. Then you are going to use this fine adjustment screw here. You are going to use this fine adjustment screw here, which will move this by very small amounts, okay? Which will move this by very small amounts. This we call the vertical fine adjustment screw. So with that, the vernier scale is going to move, okay? With that, this vernier scale is going to move. See, when you rotate this, this guy will move, this guy will move. With that, this vernier scale will move at the same time. See, clear? When you rotate this, see, this thing will move, and with that, the vernier scale will move too, okay? See, the vernier scale is also going to move. Clear? This is a screw, fine adjustment screw, microscope, and both the microscope and the vertical vernier scale, everything is going to move with the screw. Clear? So that is the basic idea of this instrument, right? That is the basic idea of this instrument. So as you see, there are some lenses they provide us. Or else you can use the lens by your own to see things clearly, okay? To see things clearly, because this is a very difficult to see scenario, okay? See, this is a very difficult to see scenario. Not a very clean instrument, okay? Not a very clean instrument. Things are written really close to each other, okay? Lines are written really close to each other. So not a very easy scenario, okay? Not a very easy way to get the measurements. Clear? So you have to like keep looking at this very carefully, okay? Keep looking at this very carefully, then try to take the measurements, okay? See, there's a lot of lines really close to each other, okay? Lot of lines really close to each other. How are you going to get a measurement is quite simple, okay? How are you going to get a measurement is quite simple. For an example, see, they have written it is 0.01 millimeters of least count, okay? It's 0.01 millimeters of least count. Clear? Vernier scale reading is 0.01 millimeters of least count. So what you're going to do is, you can see the main scale 0. You can see the main scale 0, and the main scale, sorry, vernier scale 0 you can see, okay? You can see the vernier scale 0, and the main scale you have here, main scale is in 0.5 millimeter units, okay? The main scale is in 0.5 millimeter units. If you can see properly, main scale is in 0.5 millimeter units, okay? So you are going to see, what you're going to do is, you are going to first see the last main scale division before vernier 0. This is vernier 0, this is vernier 0. You are going to see the last main scale division before the vernier 0. Now you should understand that if you are doing this practical, you have to go not at the middle, at the beginning, okay? Why? See, taking a measurement is very complex, okay? I don't see you guys, I mean, you guys live with mobile phones from like grade 1 to, I think you guys most probably can't see your eyes properly, right? Okay, clear? So I mean, you guys usually can't see things properly, right? Your generation. So you have to see, be really careful. See, it's really difficult. See, this is the vernier scale 0, this is the vernier scale 0. Just before that, you have to find the last main scale division. Then you have to see who creates a straight line, okay? See how difficult it is? You have to go through this and see who creates a straight line, okay? You have to see who creates a straight line. Then you get the measurement the same way, okay? Taking a measurement is the same way, okay? The mechanism of taking a measurement is just similar. How? If you have a main scale like this, if you have your main scale like this, let's assume that this is 50 millimeter line, then this is 50.5, this is 51, 51.5, 51.5, 52, Then let's assume, then this is 52.5 line. Then you can see the vernier scale 0 starting here. Okay. Then you can see the vernier scale 0 starting here. This is 52.5. Then you can see the vernier scale 0 starting here. Now what? Now you have to look through the vernier scale, okay? You have to look through the vernier scale, okay? Who creates a straight line? Like this, you will have the vernier scale. You have to look at the vernier scale and find who creates a straight line. So in this case, this guy creates a straight line, okay? In this case, this guy creates a straight line. So it's going to be 0, 1, 2, 3, 4. 4 creates a straight line. 4 creates a straight line. So how do we write the measurement? This is the vernier 0. Who's the last guy before vernier 0? Who's the last guy before vernier 0? It is 52.5 millimeters. It is 52.5 millimeters. See, the last guy is 52.5 millimeters plus the least count. What is the least count? It is 0.01 millimeters. It is written in the, traveling microscope. Last one before vernier 0 is 52.5. Last one before vernier 0 is 52.5. Clear? Then you go to the vernier scale, write the least count, multiply by the one who creates a straight line. So you are going to get 52.5 plus 0.04, which means 52.54 millimeters. Clear? You are going to get 52.54 millimeters. And that's not all, okay? I mean, this instrument is complex, okay? It's going to always be, that's not all, okay? There's a lot of stuff. And before like using this instrument, okay? Before using this instrument, you have to make sure that it's actually moving horizontally and vertically, okay? You have to make sure that it's actually moving horizontally and vertically. If this table is not aligned, okay? If it is inclined, it's not going to work, okay? It's not going to work. So we use what? We use the split level for that. We use a split level for that. And we use these two leveling screws to level this, okay? Guys, I was not able, I had a split level. In engineering also we need split levels. Why? Whatever the mechanisms we create, whatever the mechanisms we build, like the robotic mechanisms kind of stuff, they have to have a good stability. So we use very precise split levels. So as a result, I actually don't have any of the split levels with me at the moment, or the people like colleagues, they have stolen many of them, and like some of the stuff has been missing for a longer period of time. We usually lose a lot of stuff, okay? So, but I don't know whether this is going to work properly or not, okay? Because when I was going through my mobile phone, like iPhones come with a split level inbuilt, but I don't know whether it works or not. Let's try that, okay? We'll see whether it works. You have to go to utilities of your iPhone. Then I think, yeah, in measure, there's a category called measure. There's a split level. I don't know whether this thing's going to work or not, but let's see. Oh, it's, see, okay, it's working, kind of working. There's a -3 inclination, okay? You actually have to use a split level, okay? Don't write, okay, use the mobile phone, okay? Don't write, like, use the mobile phone. You have to use a actual split level for this. I sadly lost my split level, so yeah. These things can be used for these kind of useful stuff too. So you are going to rotate it, and this is, okay, it went to -1. It went to -1 when I'm rotating this. Can we try this camera? Cool. It's when, okay, nice. See, okay, you have to just rotate these two and make sure that it's arranged properly. See, clear? See. So iPhone do that very perfectly, okay? See, now when you rotate these leveling screws, it shows you the inclination. So you rotate it, this screw, you are going to rotate this screw, or you are going to rotate this screw. See? Okay, I can't go further with that screw. Cool. See? So the first step is you have to make sure that this is leveled. You have to make sure that this is level. So the next time when you are asking a mobile phone from your parents, tell that you need to level the traveling microscope. Okay, so that is the idea. That is the idea of this instrument. So you first level things, okay? Otherwise things will not move vertically, horizontally and vertically perfectly, okay? Otherwise they will move like this, clear? Like this. No, things has to be perfectly vertical and horizontal because we are using these measuring instruments to come up with the accuracy of 0.01 millimeter. If it moves like this, you're gonna lose that accuracy, clear? So if we tell the steps are you first level this thing. Your first step is level this thing and place whatever you need to measure in front of this or on the table. In front of this or on the table. Then you're going to rotate this, you're going to move this until you can clearly focus on whatever you need to measure. Clear? You're going to rotate this until you can clearly see whatever you need to measure. There's something called the active distance, okay? There's something called the active distance. That means when something's placed perfectly at a perfect distance. When something is placed perfectly at a perfect distance, perfectly at the active distance only you can see things, okay? Then only you can see things. So you are going to properly focus on it, okay? You are going to properly focus on it. Then get the readings, okay? After focusing on it, get the reading using the vertical scale or the horizontal scale. Then move this based on where you have to move it. Before that you have to connect these screws. Then move it where you have to move it like this. Then get the second reading. Then you're going to get the difference, okay? Then you're going to get this difference, okay? That's how things going to work, okay? There are quite a few questions I saw on the chat. Yes, one thing is, yes, we are going to do all the practicals like this. And the next one is the class plan. Someone asked, we are starting vectors next week, next Tuesday, both English medium and Sinhala medium class. We are starting the vectors. That means mechanics lesson, even the mechanics practical sessions we are going to do like this. And at the same time, we are starting an express class 2, okay? We are starting express class 2. For that, we'll be doing for 2028 batch, we'll be starting optics in this month, okay? An express class, that means with mechanics, we'll be doing optics for the students who like, okay? For the students who like, we'll be doing with mechanics. Another express class to cover optics and other lessons too, so that we can finish like 1 year before, finish the syllabus like 1 year before the exam. With that target, a new thing, that is a new thing. I think our students are capable of that, okay? We have quite a series of good students actually compared to like many other classes. So I hope so. And at the same time, within 2 weeks, we are starting weekly papers. We are starting weekly papers. So before your term test, you are going to write like, before your first term test, you are going to write like 20-30 papers. We'll give you a very nice understanding about everything. And before A-levels, you are going to write close to 100 papers, 100 or 150 papers before your exam. So I mean, then A-level seems pretty easy, okay, when you write that much of papers before the exam. So at the end of the day, our target is to make your life difficult and make your A-levels easy, okay? So that's going to be the final target, okay? So you're going to have a very hard life with us within these 2 years. But at the end of the day, you're going to write a very easy A-level compared to other students going through all these programs, going through all these problems. But at the end of the day, life would be fine because I mean, perform well in A-levels because I mean, at the end of the day, it decides what you're going to do until your end, okay? So let's move forward. Hope everything is clear. Any important questions, guys, again? Only jokes, right? Okay. Anyways, I would see like your questions like after 5 seconds or 10 seconds. There's a usual delay in the YouTube. There's no actual, I mean, there's no actual like proper human error in a traveling microscope. Why? You're going to see things very clearly. Human error comes when you can't see things clearly. Humans can't see things precisely. That's why a magnifier. That's why a vernier caliper. That's why a traveling microscope is called a microscope. That's why it magnifies 10 times. Yes, people will make human errors when they can't see things, but with this they can see things. thus it gets magnified. So very low human errors are here. Okay. Yeah, very good thing. Yes, if you place it upside down, you would see things correctly through the microscope. Yeah, you can do that. Clear? Yeah, you need to learn about clockwise and anti-clockwise movements. Very good question. Okay. Okay, you need R2 minus R1. Okay. Yeah, values are really accurate. Values are going to be really accurate. Okay. Yeah, thank you for that. Clockwise and anti-clockwise movement of the screw. That we definitely okay, two questions only. Two important questions only. Okay, another one. So clockwise and anti-clockwise movement, very important question. Why? That they may ask definitely, because they can easily check that you study all the things related to the traveling microscope, go to write A-levels, then they ask in which direction you have to rotate the screw. Now it's a problem, right? Because you have never used the traveling microscope. So it's a good question. See, when you rotate it like this, clockwise, when you rotate it like this, clockwise, it moves away from you. It moves away from you. Placing the table away from you. Place the table away from you. Okay, you are going to place the table away from you. All the scales towards your side. That's how you are going to use. Okay, all the scales from your side, table away from you. Then when you rotate this clockwise, okay, it's going to move in away from you. When you rotate it anti-clockwise, it's going to move towards you. Okay, clear? It's going to move towards you when you rotate it anti-clockwise. Got the idea? Clear? Got the idea? See? So anti-clockwise towards you, clockwise away from you. Clockwise away from you. That is the story of the horizontal scale. Let's see the vertical one. Let's see the vertical one. Yeah, clockwise down, again away from you. Clockwise goes down, away from you. That one. Clockwise away from you. See? Anti-clockwise towards you. That means up. Anti-clockwise, it moves up. Anti-clockwise, it moves up. Clockwise, it moves down. Clear? Clockwise, it moves down. Got the idea? Anti-clockwise, it moves up. Clockwise, it moves down. Clear? Okay. So that is the target. That is the target. Okay. So that question is clarified. And this R2 minus R1 thing again, another question, I answered this in the class. Okay. Isn't there any error since they are magnified? No. Why? Magnification is just to make sure that your life is easy. Okay. Magnification is just to make sure that you can see things clearly. But what actually happens is when you rotate the screws, the system is going to physically move. Not the magnified image, the system is going to move physically. Clear? So to take the crosswires, and the crosswires are physical, crosswires are not magnified or anything, right? So to move the crosswires from here to here, you have to move this the actual distance. Okay, you have to move this the actual distance. Magnification only happens later. It's only what you see. But the crosswires, the vernier scale, everything have to move physically to go from this end to this end. Okay, things have to move physically to go from this end to this end. So that is the thing. Okay, that is the thing. So you will not get any kind of error because of it's magnified. Okay, so again what you're going to do is you're going to focus somewhere like this, get that reading. You see the main scale and the vernier scale. Then you're going to move to the other end. Get the reading again using the main scale and the vernier scale. Clear? Get the reading again using the main scale and the vernier scale. Okay. Now you subtract them. Why? When you subtract them, what you're going to get is value related with this point, value related with this point, and the gap between them. Clear? Value related with this point, the value related with this point, and the gap between them. That gives me the exact diameter. Clear? That gives me the exact diameter. So that's how the instrument works. Okay, that's how the instrument works. Clear? So that is the story about a traveling microscope. Hope you got a very good idea about everything. Okay, hope you got a very good idea about everything. These things really matters when it comes to the exam results. That's why, as I always tell, 70% of the country have an S or a FY. Everyone learns things theoretically, no absolute clarity about how practicals are done, no absolute clarity about how equations are derived, no absolute clarity about how actually physics happens. Just studying a bunch of equations or studying a bunch of theory points, then you go to the exam. Now all of a sudden you can't handle them. Why? You don't know how things actually happen. You only have a knowledge with a book. Okay, so that's what we are gonna eliminate here. Okay, so we have to try to go for a very high pass rate and a percentage as we used to do. Okay, so in the normal class we are planning to finish the syllabus like 6 months before the exam, and we have done this for 26 batch, 25 batch, 24 batch, 22 batch. You can check with the seniors, and we are really going there with the 27 batch too. We are doing 2 lessons at the moment, heat and optics, for 27 batch, and for 28 batch also we are starting the express program to start things, finish things 1 year before the exam. That didn't happen for previous batches, but at the same time the normal batch will be finishing the syllabus 6 months before the exam. Then you have enough time to do anything. Okay, so that's our usual plan, and whatever the plan we tell, we have done until now. Okay, that's the usual nature of our class. You can check with our seniors. Whatever the plan we mention in the class, we do that. Okay, we never lie. Okay, so let's move forward. Let's move to the other instruments. Okay, let's move to the other instrument. Why did I tell that? That question arises always. Okay, that's fine. So let's move to the other set of instruments, quickly go through the other stuff, then return to theory points and everything else. Okay, so the other ones would be, another principle that we are going to use is the principle of screw. The principle of screw. For that we are going to use this. This would be used in the principle of screw, the micrometer screw gauge, and the spherometer. The spherometer will be using the principle of screw. Okay, so let's move to the principle of screw. The other link. Okay, let's move to the principle of screw. So I'll keep this aside. These are the 2 main instruments that we are going to use next. Okay, these are the 2 main instruments that we are going to use next. So there's a screw rotating like this. There's a screw rotating like this. See, screw rotating like this, and this gap between 2 points, we are going to call that a pitch. And that pitch we divide into like in this case 100 divisions. See, we have divided it into 100 divisions. Clear? We have divided it into 100 divisions. So what's going to be the value of a smaller circular division in this case? What's going to be the value of a smaller circular division in this case? That is going to be if we tell the pitch is 1 millimeter, so the pitch is 1 millimeter. Pitch means the gap. Pitch means the gap. This is the pitch. This is the pitch. In the instrument that I showed, it is 1 millimeter. So when we rotate this screw 1 full circle, it's going to move 1 millimeter, and that 1 full circle we have divided into 100 circular divisions. Okay, we have divided it into 100 circular divisions. Clear? So what would be the value of 1 circular division? What would be the value of 1 circular division? That is the least count. Least count. Value of 1 circular division would be 1 millimeter. 1 millimeter divided by, if it is 100 circular divisions. Okay, so it's going to be 0.01 millimeters. Okay, clear? It's going to be 0.01 millimeters. That is the usual least count of the instrument. Okay, that is the usual least count of the instrument. Okay, so it's the same scenario with the micrometer screw gauge too. Okay, with the micrometer screw gauge too, it's the same scenario. Okay, there's a screw, and there's a rotating system like this. And how are we going to get measurements? As you see here, you have a main scale, and you have a circular scale. Okay, you have a main scale and a circular scale. Here also you have a main scale. In this instrument also you have a main scale and a circular scale. So just like in the vernier caliper, after quite a bit of rotation, what you're going to do is you're going to get the main scale reading. So if it is, in this case, if it is 6, if the main scale reading shows 6, if the main scale reading shows 6, first the main scale reading is going to be 6 millimeters, then plus, then you're going to get the circular reading that you see. Okay, you're going to read whatever the circular value you see here. Okay, so things are shining. Okay, don't worry about that. It's not going to shine like that when seen through your actual eyes. Okay, clear? We see, we'll try to find an angle that you can see things. No, right? No worries about that. So it's actually 99. It's actually at 99. The circular scale shows 99 like this. See, it's very close to 0, but it's not actually 0. It's at 99 in this case. Okay, it's at 99 in this case. Clear? See, it's kind of before 0. This is 0. This is 1 unit before 0. This is 0. Here you can see 0. Here you can see 0. This is 1 unit before 0. It's only 1 unit before 0. That means it's going to be 99. So 6 millimeters through the main scale and 99 through the circular scale. And what is the value of one circular unit? Value of one circular unit is this, right? Value of one circular unit is this, 0.01 millimeters. 0.01 millimeters. Value of one circular unit is 0.01 millimeters. Then it's going to be 6 millimeters plus 0.99 millimeters. It's going to be 6 millimeters plus 0.99 millimeters, which is going to be 6.99 millimeters. Clear? It's going to be 6.99 millimeters. That is going to be the reading. Okay, that is going to be the reading. That's how this instrument works. So with the micrometer screw gauge, it's the same story. You have 0 here, main scale 0 here, circular scale 0 here. Okay, main scale 0 here and circular scale 0 here. And what you're going to do is we are going to rotate this. So as you see here, in this main scale now, there's like 0.5 millimeter divisions. 0.5 millimeter divisions too. Okay, there's like 0.5 millimeter divisions here. Okay, see, there's like 0.5 millimeter divisions here, and the circular scale has like see, 45, 46, 47, 48, 49, 50 divisions. Circular scale has 50 divisions. So again, you can get the least count like that. Okay, how? You can get the least count by the size of a main scale division is 0.5 millimeter. Size of a main scale division is 0.5 millimeter divided by size of a main scale division is 0.5 millimeter, then divided by 50 circular scale divisions, right? 50 circular scale division. So the least count is going to be 0.01 millimeters. 0.01 millimeters. Provide a contact number. Some students ask for that. Okay. So it's going to be 0.5 millimeters divided by, and I think we can provide you our community link too. If you don't have that, we can provide you our community link, and at the same time the contact numbers too. Okay, for any issues, for recordings, for things you have missed. Okay, for the things you have missed, for any recordings, for anything, you can contact that number. Okay, that is available in the chat. Okay, in the live chat. So the least count is going to be 0.01 millimeters. Clear? Least count is going to be 0.01 millimeters. So next, when you're taking a reading, what we're going to do is, okay, when taking a reading, what we're going to do is, again, just like the vernier caliper, get the last main scale reading. 0, 0.5, 1, and again about that least count, when doing the practical, you don't have to worry. Okay, why? It comes written on the instrument usually. Okay, it comes written on the instrument. It is 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. The last main scale reading is 4 millimeters. Okay, last main scale reading is 4 millimeters. Okay, then the circular one is 45. See, the circular one is 45. So it is 4 millimeters and 45. So we can write it is 4 millimeters. It is 4 millimeters plus, it is 4 millimeters plus 45 into, what is the least count? We got, it was 0.01 millimeters. Okay, it's 4 millimeters plus 45 into 0.01 millimeters. Clear? Okay, so it's going to be 4.45 millimeters. Clear? It's going to be 4.45 millimeters. That's how we get a reading. Okay, and there was a question. Yes, this time we are trying to do like this time the class is going to happen like we are going to do the class, do the theory points, do all the practicals and different application kind of stuff at the lab, show you how things actually happen, give you a very good clarity about everything. Then towards the end of the lessons, like after like doing 5-6 lessons together, we'll combine all the practicals and we'll be doing workshops for that. Okay, so even the online students can come physically and see the workshops, actually use the instruments. So this time the 28 batch program has arranged in a way that, I mean, you're not going to miss anything. Okay, this time you're not going to miss anything. You're going to see live demonstrations like this. You're going to learn all the theorems, separate questions, separate papers, and at the same time, at the end of the day, actual physical practicals. Okay, so this time the things are arranged in a way that, I mean, when we have quite a bit of students, a huge number of students, we have to do everything possible, because I mean, you have to make sure that everyone gets a result, a perfect result actually. So that's the plan this time. So that is the whole idea of a micrometer screw gauge. Okay, that's the whole idea of a micrometer screw gauge. That's how you're going to get a reading. Okay, clear? That's how you're going to get a reading. So in that case, like using this instrument, okay, using this instrument is a different thing. Okay, clear? Using this instrument is a different thing. That's how you get a reading. Okay, but when you're using this instrument, it comes with a very specific mechanism. Why? This vernier caliper, the problem with this vernier caliper is, okay, this may harm anything. Okay, this may harm anything. Why? See, these are very sharp jaws. Okay, these are very sharp jaws here. Clear? These are very sharp jaws here. It can harm things. If I put a lot of pressure on this, it will break this glass. Okay, if I put a lot of pressure on this, it will break this glass. Okay, but the thing is, when I'm using a micrometer screw gauge, it comes with a pressure release mechanism. This part is a pressure release mechanism. That means it's not going to destroy whatever you are measuring. Okay, let's assume that you have to measure this one. Okay, let's assume that you have to measure this one. So what you are going to do is just rotate it like this, move forward, but towards the end, don't use that, use this. use this. Rotate it using this. Why? When it provides enough pressure, it's going to release. See? It's going to release. See? It's going to stop moving forward. See? It's going to release. The mechanism is going to release. Okay? The mechanism is going to release. Clear? So it will stop moving forward. Otherwise, if I keep pushing a different instrument, it will destroy this. Okay? It will just, it can harm a wire, it can harm a glass, it can harm anything. But in this case, it's going to stop. It's not going to move forward. Okay? It's not going to move forward. Okay? Then what you can do is you can connect this pin. Then it stops moving. When you connect this, it stops moving. Then you can peacefully get the reading, peacefully get the main scale reading and the circular scale reading. Okay? You can peacefully get the main scale reading and the circular scale reading. See, the least count comes printed. 0.01 millimeters. 0.01 millimeters. Least count comes printed. That's why I always tell finding the least count is not a big deal when it comes to the actual practical at the lab, because it comes printed. Okay? It comes printed. So that is the usual mechanism. Okay? That is the usual mechanism of a micrometer screw gauge. Okay? That is the usual mechanism of a micrometer screw gauge. But this pressure release mechanism doesn't work with things that can be distorted. Okay? It doesn't work with things that can be distorted. For an example, if I place my finger here, okay, I actually need to measure the size of my finger. Okay? But it's going to deform my finger before this pressure release mechanism works. So, see, now at the moment my finger isn't deformed. Okay? Finger isn't deformed. But when you keep rotating it, even using the pressure release mechanism, it's going to deform the finger a bit. See? It's going to deform the finger a bit before the pressure release mechanism works. See, now the pressure release mechanism works, but I feel that I'm going to lose my finger. So the pressure release mechanism doesn't work perfectly. The pressure release mechanism doesn't work perfectly with things that can be deformed. So it's not going to work with rubber or anything like that. Okay? It's not going to work with rubber or anything like that. Things that can be deformed. Okay? Things that can be deformed cannot be measured using this. Okay? Yes, it has a pressure release mechanism. Any rigid body like glasses, anything, any rigid body, okay, this can measure and it will not harm any rigid body using this pressure release mechanism. But the thing is, it's not going to work with something that's going to deform. So for something that's going to deform, okay, for something that's going to deform, the solution is going to be again our previous instrument, which is the traveling microscope. Okay, the usual solution for anything that can be deformed. What we are going to do is we are not going to go near. We are going to look from a distance and measure. Okay, we are going to look from a distance and measure. Clear? So that is the usual criteria on how we'll be choosing the instruments. Clear? That is the usual criteria of how we'll be choosing the instruments for different purposes. Okay. And the next instrument is the spherometer. So the same mechanism. Next instrument is the spherometer. Okay, which has the same mechanism. Has a main scale. Clear? Spherometer has a main scale. Clear? And a circular scale. So we are going to get readings using the main scale and the circular scale. Getting the readings is just similar. Okay, getting readings just similar, but towards the end of the class, I'll again revise how to get the readings and all these theoretical parts. Okay, all these theoretical parts I'll repeat. Okay, towards the end of the class, the theoretical parts I'll repeat. But now let's focus more on the practical. So this can measure something, stuff going above. Okay, so it has a center zero. Okay, what it has is it has a center zero. Clear? It has a center zero. So it can measure something up. It can measure something up. The screw can go up and measure something. Okay, the screw can go up and measure something, or the screw can go down and measure something. The screw can go down and measure something. Clear? The screw can go down and measure something like this. Okay, so while measuring, how do we measure things using this? The first thing is we are going to place this. Okay, first thing is we are going to place this on a glass block. Okay, I actually lost the glass block, so I found a prism. Even the prism is a glass block, okay? Even the prism works as a glass block, okay? So what we are going to do is we are going to place this on the glass block like this. We are going to place it on a horizontal glass block like this. See, now it's not balanced. See, now it's not balanced. So what we are going to do is we are going to make sure that everything comes to the ground level perfectly. We have to make sure that everything comes to the ground level perfectly. How are we going to confirm that? We are going to place it on the glass block and place it like this. Now hope you can see, okay, hope you can see there's a very slight reflection. There's a very slight reflection you can see through the glass block. See, a very rough reflection. See, a very slight reflection you can see from the glass block. So what you are going to do is you are going to make sure that this pin is going to touch its image. See, this pin is going to touch its image. Clear? For an example, if I use the pen, see, this pen should touch its image. See, the pen should touch its image. That I have to make sure. Clear? That I have to make sure. So before measuring anything, you have to make sure that things are aligned flat. Okay, things are aligned flat. So when things are aligned flat, how do we identify whether the things are aligned flat? How are we going to identify is the pin, the center pin and its mirror image, not the mirror image means the reflection will touch each other. Center pin at the reflection will touch each other. You can never do this with a mirror, as I mentioned, okay? Clear? You can never do this with a mirror, okay? You can never do this with a mirror, as I mentioned. Why? See, this is a mirror. This is a mirror. When you place it on a mirror, there's always a gap, okay? When we place it on a mirror, say, there's always a gap. It's very clear, okay? The mirror is very clear. Now even the pin is touching the mirror. Center pin is touching the mirror. But there's always a gap, okay? See, through a mirror, see, through a mirror, there's always a gap. Why? Reflection doesn't happen at the surface in a mirror, okay? Reflection doesn't happen at the surface of a mirror. It happens at a layer below. It's a mercury layer. It happens at a layer below. It's a mercury layer. Okay, so see, here it's a mirror. Oh, this window. Okay, see, there's a huge gap here. See, there's a huge gap here. Clear? Okay, so even your finger, see, see, there's a huge gap. They will never touch each other, okay? They will never touch each other. In the glass, you can't see things clearly like this. But it's going to happen, okay? It's going to happen. In a glass, you can't see things clearly like this. Why? A glass is not made for reflection, okay? A glass is not made for reflection, clear? So glass won't show you a nice image like this. But glass will make sure that your reflection touch the pin at the right moment, okay? So in a mirror, what actually happens is, there's a glass surface and a mercury surface. There's a glass surface and a layer of mercury. Mercury is a very good reflector. So what's going to happen is the reflection happens here, okay? What's going to happen is the reflection happens here, clear? Reflection is going to happen here, clear? Okay? So you will never see them touching each other. So to make sure that the things are flat, that means all the things are at the ground level. To make sure that all the things are at the ground level, okay? To make sure that all the things are at the ground level, what you do is you use a glass block so that the pin will be touching its image. Pins will be touching their images. So we know for sure that things are properly placed, okay? We know for sure that the things are properly placed and all the legs are properly leveled. Then we are going to get this reading. Then we are going to get this reading at this moment, okay? Then we are going to get this reading. See, there's a main scale reading here. There's a main scale reading here. And there's a circular scale reading here. When things are leveled, there's a main scale reading here and a circular scale reading here. So actually we expect it to be 0, 0, okay? Clear? We always expect it to be 0, 0 actually. Clear? we expect it to be 0, 0. That means a main scale 0 and a circular scale 0, but it never works like that, okay? It never works like that. Usually spherometers have big errors. So it won't be 0, 0 actually. There will be gaps, okay? There would be gaps. It won't be a perfect 0, 0. So what we are going to do is we are going to get the reading. So in this case, as I saw, the reading is you have 0 here, 1 millimeter here, 2 millimeter here, 3 millimeter here. And at the beginning, you have the circular scale like this. At the beginning, you have the circular scale like this, and the circular value is perfectly 55. It's going to be perfectly 55. As I see, it's going to be perfectly 55. So the least count of this spherometer is 0.01 millimeters. Okay, how do I know? How do I know? See, the main scale divisions are 1 millimeter divisions. Okay, main scale divisions are 1 millimeter divisions. Okay, main scale is in 1 millimeter units. Okay, main scale is in 1 millimeter units, and the circular scale has 100 units. Okay, that means the pitch is 1 millimeter. That means the pitch is 1 millimeter. Pitch is 1 millimeter, and the circular divisions, number of circular divisions is 100, which is going to be 0.01 millimeters of least count. Okay, least count is 0.01 millimeters. Clear? Least count is 0.01 millimeters. So how do we get the reading? Last guy on the main scale is 0. Last guy on the main scale is 0. So it's going to be 0 millimeters. It's going to be 0 millimeters plus the circular scale value is 55. Circular scale value is 55. Clear? The circular scale value is going to be 55 multiplied by the least count. Multiplied by the least count, which is 0.01 millimeters, which is going to be 0.55 millimeters. Clear? Which is going to be 0.55 millimeters. So this is the measurement at the beginning. That means when everything is leveled properly. When everything is leveled properly. Clear? When things are leveled properly. Clear? Then if you need to measure the height of something, okay? If you need to measure the height of something, so we'll see, can we like find something smaller? That means I can't measure the height of this. I can't measure the height of this. Why? See, why can't I measure the height of this? See, pins are placed outside. I can't place the pins outside. See, I can't place the pins outside. Clear? I should be able to place these pins, legs outside and the pin at the middle. So all what I can measure is something really small only. Okay, can we find a coin? Okay, let's try to find a coin. A smaller coin only. I mean, why? Something very small. Something very small only we can place in between these legs, right? Clear? Something very small only we can place in between these legs. Okay, so we have a coin. See, when it comes to a coin, it can be placed in between. See, it can be placed in between. Now what we are going to do is we are going to make sure that the legs are placed outside. We are going to make sure that the legs are placed outside, and you are going to touch the pin on the coin. You are going to touch the pin on the coin like this. Clear? You are going to touch the pin on the coin like this. Clear? Okay. So now you can get the reading. Now you can get the reading. From the main scale it shows like 0. From the main scale it shows like 0, 1, 2. 0, 1, 2. From the main scale it's gonna see like 0, 1, 2. Okay, 0. It's going to be the 0 millimeter, 1 millimeter, then 2 millimeter. Okay, from the main scale it's going to be 2 millimeter, and from the circular scale it's going to be 20, 21, 22, 23, 24. It's going to be 24 here, okay? It's going to be 24 here. So it's 2 and 24. So the main scale reading is 2 millimeter. Main scale reading is 2 millimeter. Okay, main scale reading is 2 millimeter, and the circular scale reading is 24. Okay, circular scale reading is 24. Then you multiply this by 0.01 millimeter, which is the least count. Okay, you multiply this by 0.01 millimeters, which is the least count. Then we are going to get 2.24 millimeters. Clear? Then we are going to get 2.24 millimeters. This is going to be the value. Then what is the actual height of the coin? Actual height of the coin is going to be the difference of these two, right? Actual height of the coin is going to be the difference between these two, which means 2.24 minus 0.55 millimeters. Clear? 2.24 minus 0.55 millimeters. Clear? This is going to be the reading. Okay, this is going to be the reading. Clear? So any problems until now? Any problems until now? And hope you are coming to event, right? As I remember on June 15th. Okay. Okay. Hope you are coming to our event. There would be a lot of fun stuff, activities, a cricket match, dodgeball, and like what else? Food, DJ, everything. So I mean, yes, we can't only learn, right? Yeah, so there's going to be that kind of stuff too. So hopes you'll be coming. Okay. You are welcome to that too. You are welcome to learn and you are welcome to have fun, both. Okay. You have to do both. Okay. So any questions? Any questions? Yeah, proof of the equations I'll do. Okay, proof of the equations I'll definitely do. Clear? Proof of the equations I'll definitely do. Yeah. Yeah, click sound will be produced. Yes. Yeah. Click sound will be produced in a micrometer screw gauge for sure. Okay. It will produce a click sound when the pressure release mechanism starts. Okay. When the pressure release mechanism starts, a click sound will produce. Oh, the most important question: when would you get O-level results? That's the only question you have, right? Now it's really close, by the way. Okay. We'll think like within 2-3 days. Okay, how to join the match and all. Information will be provided in the group. Okay. Team registrations and everything is provided in the group. Okay, be quick. Okay, so all the information about the event is provided in the group. Okay, be quick and register. So so that is the story of a spherometer. That is the story of a spherometer. But the thing is, that's not the only thing that we use a spherometer for. Okay, this is not the only practical usage of a spherometer. There's a way more important practical thing, that is measuring the radius, circular radius of a spherical surface. Measuring the circular radius of a spherical surface. Clear? So for that, what we again do is we are gonna place this on a glass block. We are gonna place this on a glass block and make sure that everything is properly flattened. Okay, we are going to make sure that everything is properly flattened. Clear? So in that case, again we'll be getting this result, right? When everything is properly leveled. Okay, when everything is properly leveled, this is the value that we would read. Okay, this was the value that we read when things are properly leveled. Now the next thing is we are going to get a spherical surface. we are going to get a spherical surface, and now make sure that all the pins are touching the spherical surface. Have to make sure that all the pins are touching the spherical surface. That we have to make sure. Okay, that we have to make sure. Clear? We have to make sure that all the pins are touching the spherical surface. Okay, so in that case, okay, even a lens is a spherical surface, right? Even a lens is a spherical surface. See, now at the moment it's not balanced. See, it's not balanced at the moment. So I have to make sure that I rotate this and all the pins are properly placed on the spherical surface. I can identify, see, when it's not placed properly, it's not balanced on the spherical surface. See now, see, still there's a small gap. Have to make sure that now everything, now it's a bit above. Now it's a bit above. I have to make sure that it's touching the spherical surface properly. Now I think it's okay. See, the reflection and the pin is touching each other. Can you see? Can you see that the reflection and the pin is touching each other? See, the reflection and the pin, they are touching each other. Got the idea? That's how we identify that they are touching. Okay, there's a reflection, see, slight reflection, and the pin, they are touching each other. Now I'm going to get the reading. Okay, now I'm going to get the reading here. In this case, in the main scale, I can see like 1. In the main scale, I can see 1, and here I can see 2. In the circular scale, I can see 2. In the circular scale, I can see 2. It's very close to 0. It's very close to 0. So in the circular scale, I can see 2. And in the main scale, I can see 1. Okay. So in that case, it's going to be 1 millimeter plus 2 into 0.01. 1.02 millimeters. Okay. 1.02 millimeters. So now what is the actual height here? What is the actual height here? H. That actual height would be 1.02 millimeters minus this 55, right? Reading here was 55. Reading here is 1.02. So what is the difference? That gives me this height, 1.02 minus 0.55 millimeters. 0.55 millimeters. Clear? Can I get the answer here? Can I get this answer? Solve this. Okay. So the next one. Now I know the height. Okay. Now I know the height. Okay. Now what I have to do is I'm gonna take this. And press this against. Okay. I'm gonna take this and I'm gonna press this against a piece of paper. 0.47 it is. I'm gonna press it against a paper. This is 0.47 millimeters. 0.47 millimeters. That is this height. H. Okay. So the next what I'm gonna do is I'm gonna take this and I'm gonna press this against a A4 sheet. I'm gonna press this against a A4 sheet. Okay. So what happens when I press this against A4 sheet? It will create 3 dots. See? It will create 3 dots. I can see 1 dot here. I can see 1 dot here. 1 dot here. And the other dot here. Okay. I'll be seeing 3 dots like this. Now what I'm gonna do is I'm gonna draw lines between them. I'm gonna draw lines in between them. So now to measure this distance, we usually use a meter rule, okay? To measure this distance, we usually use a meter rule. I mean, this is just a hectic and large instrument. So I'm gonna just use like the normal ruler that we always use, okay? I'm gonna use the normal ruler that we always use, which is the ruler, okay? The ruler. So, you know, in a ruler, how we get measurements, right? We don't use zero. We don't use zero. We use something in between. See? Now here, I place it like this, okay? We place it like this. So here the value I'm reading is 5 millimeters, sorry, 5 centimeters. Here the value I'm reading is 5 centimeters. This is the 5 centimeter line. 5 centimeter means 50 millimeters. What is the value here I'm reading? What is the value here I'm reading? Look like this. 7.567, right? 7.5, 7.6. It's 7.7 roughly, I think. Yeah, it's going to be 7.7 centimeters, which means 77 millimeters. So what is the difference between these two? Difference between these two, 77 millimeters minus 50 millimeters, it's going to be 27 millimeters, okay? It's going to be 27 millimeters. So what I'm going to do is I'm going to measure this one, I'm going to measure this one and get the mean, okay? Get the mean, okay? Let's assume that we are getting 27 millimeters here too. Let's assume that we are getting again maybe 28 millimeters here. So to measure the gap between two legs, I'll call that A. To measure the gap between two legs, what I'm going to do is I'm going to add these two, 27, 27 and 28. 27 plus 27 plus 28 and divide it by 3. Okay, I'm going to get 27 plus 27 plus 28 and divide it by 3. Clear? So that we get 27.33, right? 27 plus 27 plus 28 divided by 3. Clear? So there I'm going to get 27.33 millimeters. Okay, I'm going to get 27.33 millimeters. So gap between two legs, okay, we read as 27.33 millimeters. 27.33 millimeters. Okay, this is the gap between two legs. Any problems, any issues you have until now? Anything? Anyone facing any issues until now? Okay. And I asked you that I mentioned that you can derive these equations if you like, right? Okay. Okay. Yeah, I'll show that. I'll show you how it's done. Yeah, I mean, we can actually use 0, okay? We can actually use 0, but we usually don't use 0, okay? In a meter ruler, that was just a convention, okay? That was just a convention. What is that 0.55? That is the reading when things are flat. 0.55 means the reading when things are flat, okay? 0.55 means the reading when everything is at the ground level, when things are flat, okay? when things are flat? It's 27. Which one? Okay. Okay. So it's when things are flat, it's 0.55. Then after that, you get when things are elevated. That is the difference. Okay. That is the difference. Okay. So do we have anything changed? Which one? This it is 27 point. It should no. It should be 27 plus 27 plus 28 divided by 3. No, you see. Guys, we are not good at calculations anymore after longer usage of calculator. 27 plus 27 plus 28 divided by 3. It's 27.33. It's correct. Yeah, 27.33. Clear? Okay. So now, what's next? Now I have an equation. Okay, this equation I showed you how we derive things. Okay, I showed you how we derive things. So that was a squared over 6h plus h over 2, right? Clear? Hope you can remember things. Hope you can remember things. Did anyone was able to derive that equation? Just tell me. Did anyone was able to derive that equation? Anyone? Sorry, I mean it should be inverted, right? The equation should be opposite. It is a bit different. I'll write it in according to your notation. But just tell me, was anyone able to derive this equation? Oh, there's a question related to the tude too. There's a question, someone's mentioning a question related to the tude too. Page number? Page number? Give me a second, we'll check. I'll go to the tude. Okay. That statement related to the traveling microscope. I'll talk about that. Okay. I'll talk about that. I'll talk about that anyways. Okay. So don't have to worry about that. So anyways, there are some students. Yeah, some students who have get that equation. Okay. So this gives us the radius. Okay. This gives us the radius. So for anyone who likes to derive this, next week I'll again show this how to derive this in the class. But I mean, it is just like this. Okay. There's a sphere like this. This is the sphere. This deriving this is not in the syllabus, okay? But I mean, you are science students, so it's good to know these things. So this is the radius of the sphere. That's what we are finding. This is the radius of the sphere. That's what we are finding. This is the height we measured. This is the height we measured. And these are the 3 pins. These are the 3 pins. This is the center pin between 2 legs. Okay. Between 2 legs, what we get is A, and A. And these are 60-degree angles. These are 60-degree angles. So you can calculate the actual length of this. You can calculate the actual length of this x. That means from one leg to the center pin. You can calculate the actual length of this from one leg to the center pin. That is this length. That is this length. So this is the radius r. This is x. that I get from this triangle. This is again the radius r. So what is this distance? This distance is r minus h. This distance is r minus h because this is the radius, this is r, this is h. So this becomes r minus h, this becomes r, this becomes x. So what you do is x squared Pythagoras, apply Pythagoras to this triangle, apply the theorem to this triangle, x squared plus r minus h squared equals r squared. You would get a quadratic equation. You solve this and get the value of r. Okay, that is how we derive this equation. So it doesn't come out of nowhere. Okay, this equation doesn't come out of nowhere. It's just a mathematical result. Okay, just a mathematical result. Okay, a very simple mathematical result. If you like, you can try to solve. Okay, if you like, you can try to solve, but it is not in the syllabus. But I repeat, you guys are science students, so it's good to try. Okay, it's good to try. Okay, so what we are going to do is, we have this equation. So in the syllabus, what we have to do is just use the equation. So it's a squared over 6h plus h over 2. A squared over 6h plus h over 2. So what is a? This 27.33 millimeters squared over 6h. Again, what is h? 0.47 millimeters. 0.47 millimeters plus again h 0.47 millimeters over 2. So like that you can easily get the radius. Okay, like that you can easily get the radius. Clear? And this works for convex stuff and concave stuff both. Okay, this works for convex stuff and concave stuff both. Okay, a squared over 6h plus h over 2. You are going to use this equation, and this is how you derive it. But it's not essential to do this, but I'll do this in the class. Okay, so that's how things happen. That's the usage of spherometer. Clear? That is the usage of spherometer, how we do a practical using a spherometer. Okay, that's how we do a practical using a spherometer. Okay, got the idea, everyone? Okay, so that's the whole point of using all these instruments. Okay, that's the whole point of using all these instruments. So okay, so hope you got a good clarity about this instrument. Okay, hope you got a good clarity about these instruments, how are we going to use them and all. Okay, so the interesting parts are over. Okay, interesting parts are actually over. That means how the instrument is going to be used and kind of stuff are over. Now I mean, let's move back to some theoretical stuff. So feel free to, I mean, it's okay to leave. Okay, it's okay to leave now. We have already finished the important stuff, how the practical is being done, but there's quite a few questions remaining there. Okay, there's quite a few questions remaining there. I'll answer them, and at the same time some people need to learn the theoretical stuff again on how the Verniers concept was like derived, how the micrometer concept was derived, this kind of stuff. I'll quickly go through them. But how the instruments are used, the practical usage. Okay, how the instruments are used, the practical usage part is over. Hope you learned something properly, and we'll meet in the class. Okay, we'll meet in the class. So I'll move to the theoretical stuff. Only if you need to learn those theoretical stuff again, which we did in the class, you can stay in the session. So let's continue. Okay, others, just mention about the session, just mention something about the session, and it's okay to leave. Okay, it's okay to leave. Others, if you need to learn the theoretical stuff again, you can stay in the class. It's very difficult to understand what you guys are telling. You guys are like, it seems like you're using a different language actually. just put all the questions you have now, okay? Our main part is over. Now the answering questions, doing theory again. Now it's that kind of part, okay? It's that kind of part, answering questions again, like going through the theories again, that part. So just mention in the chat whatever the questions you have. Yeah, I mean, camera team is doing a great job, right? So it's from the Sysygy online studio, Sysygy online Mahagedera, we are doing the session. So they are doing actually a great service. Like, I mean, otherwise you can't see the practicals properly, right? We can't do this using one camera. That's why we are not capable of doing this in the main class. It's not actually necessary to join the fast track, but it's good. Okay. Okay. Yeah, the first part of the syllabus you can get our details. You can join our community. There's a contact number 2. Okay, there's a contact number 2, and you can join. Yeah, the parallax errors. Yes, errors also I'll try. Errors also I'll try to like discuss a bit. Any other questions? You're starting A-level physics after switching streams. It's not a big deal. You haven't missed a lot. Join the class next week for sure. Okay, join the class next week for sure. You're starting a new lesson, and you can watch the recordings and cover the previous parts. No, width of the crosswires are not big, so it won't affect the reading, okay? Width of the crosswires are not big, so it won't affect the reading. Okay, so moving back to the theory points and answering some questions you asked. What batch will you stop doing tuition classes? It's a very unnecessary question from a person at my age, right? Can I join for the cricket match online? Another one answering yes from the Zoom ground. No, you can come physically, yeah. Okay, so talking about the other remaining parts, okay, other remaining parts like for the students who required, okay, talking about the remaining parts for the students who need to learn these. So I'll be answering some questions. Yes, so when there is a zero error, yes, when there is a zero error on a vernier caliper, what may happen is it may create a gap like this, okay. When there is a zero error in a vernier caliper, it may create a gap like this, okay. It will create a gap like this. So although you measure something, although there's nothing here, this rust here will occupy a certain length. So you will have a starting value, okay. So you will have a starting value. So what you have to do is you have to get the starting value first. You have to get the starting value first, then get the measurement, whatever you need to measure, then subtract them, okay, clear. But the rust here won't affect these jaws or the depth probe, okay. These parts are just for support when you are placing the depth probe, okay. These parts are just for support when you are placing the depth probe, clear. When you are placing the depth probe, these parts are just for support, clear. Now next, yes, the sperometer, when it gets rusted, the screw gets loosed, yes, then it doesn't move straight anymore. It will move inclined, okay. Then it won't move straight anymore. Then it will move inclined, okay, clear. It will move inclined. Then you can't trust the main scale anymore, clear. You can't trust the main scale anymore when it is moving inclined, clear. You can't trust the main scale anymore when it is moving inclined. Okay, so this is the circular scale. Okay, this is the circular scale, but still you can believe the circular scale, but it's gonna rotate. It's gonna rotate. Now there was a question on how to show this. See, when it is moving up, see, this question arose in the class too. When it is moving up, it moves like 0, 1, 2, 3, 20, 30, 40, 50, 60. But when you are moving this down, it goes like 0, 19, 90, 80, 70, 60. So when you are moving up only, you would see 0, 10, 20, 30, 40, it's increasing properly. Okay. When you are moving up only, you would see it's increasing. See, it's increasing. When you are moving down, it's gonna decrease. See, when you are moving down, it's gonna decrease. Go from not actually, from 0, that means 100, it's going to go 99, then 90, then 80, then 10. Okay, so that's how the spherometer works. Okay, when you're going up, it's going to increase the values. When you're going down, it's going to decrease the values. Based on that, we explained you how to get the readings. And there was a question, yes, we can use the vernier caliper to measure this gap too. Okay, we can use the vernier caliper to measure this gap too. How? If you like, you place the vernier caliper like this, then like this. Clear? You place the vernier caliper like this, then get the measurement. Clear? If you like, you can get the measurement like this. Get the reading here, then you can get the gap. That was another question. Just like taking another reading. Okay, just like taking another reading. And the next one, talking about the vernier principle. So micrometer principle is already clarified, I think. Talking about the vernier principle for the students who asked. I'll check whether there are any other questions. So now, like talking about the another thing, using the meter ruler, someone asked a question. Yes, so this is the meter ruler. We are not going to talk about this because it's very common instrument. But this is how we place a meter ruler. Can you remember? If you need to measure something, you are not going to place the meter ruler like this. Okay, we are not going to place the meter ruler like this because then there's a gap. See, there's a height. So how we place the meter ruler is like this. Okay, how we place a meter ruler is like this. See, then there is no gap. You can see things directly. They are touching each other. Okay, that was one question about the meter ruler. Okay, that was one question about the meter ruler. Then another question about the parallax error. The traveling microscope will never create a parallax error. Why? You are directly aiming where you need to measure. Okay, you are directly aiming at where you need to measure. Clear? In a traveling microscope, we never make a parallax error. Why? It's not like the object, yes, the object and the instrument is at a distance, but you are directly aiming at where you want to see, right? You are directly aiming at where you want to see. So there, it won't create an actual gap. Okay, it won't create an actual gap. Clear? You are directly aiming at where you want to see things. Clear? That's how it works. Okay, so the next thing, so it won't create a parallax error. Okay, it won't create a parallax error. Okay, in the meter ruler, yes, it may create a parallax error. Okay, why? If you need to measure the height of this guy, you can't. Why? See, you can't place it. See, there's a gap. See, there's a gap. There's a gap here. See, there's a gap here. A gap you can't bridge. Okay, so see, there's again a parallax error. Okay, there's a parallax error. See, clear? You can't do things like this, right? So there's a gap. Okay, but in the traveling microscope, if you need to measure, you focus here from a distance, then you focus here from a distance. You focus here on from a distance, you focus here from a distance. There's no parallax error. It's going to eliminate the parallax error. What is parallax error? The error due to the gap between the object and the measuring device. Okay, error due to the gap between the object and the measuring device. And Okay, so quickly talking about the vernier principle fast. Okay, and again there was a question, no, you don't have to like derive this equation, you can just put values. Okay, you can just put values. This is the gap between two legs, this is the gap between two legs, and this is this height difference that you get by placing it on a flat surface and placing it on a sphere. Okay, this is h that you get by placing it on a flat surface and placing it on a sphere. That is h, that difference that you directly put here. Okay, that h you directly put here, and this radius, that the gap between two legs, you get the mean value and you directly put here. Okay, and you directly get the answer. This is the answer, the radius, the circular radius of the sphere. I explain you how to derive that. You can try that if you like, but it's not mandatory because it's not in the syllabus. Okay, it's not in the syllabus, so it's not mandatory. Okay, so someone asked me about the, and I think micrometer principle is, or the screw principle, the principle of screw is clear, right? Okay, principle of screw is clear, right? It's just you have a pitch, that means you have a gap, a small screw. Okay, you have a gap, a small screw, clear? You have a gap and it has pitch. Pitch means a small gap between these two, and when you rotate this one full circle, it will move down one pitch. So this circular scale we use to divide the pitch. You get the pitch divided by 100, you get the size of one circular division. You get the reading from the main scale, then you get the reading from the circular scale. Okay, you get the reading from the main scale, then you get the reading from the circular scale. These two together gives you the result. Okay, so the principle of screw is simple like that. Okay, from the main scale we get what is the distance traveled through the main scale, then using the circular scale. Okay, using the circular scale we read, okay, using the circular scale we read what is the value, how many circular divisions we have moved after that. Okay, using the circular scale we read how many circular units we have moved after that. Talking about the vernier principle, it's like this. Okay, you have a main scale, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the main scale. What you do is you get a vernier scale. What you do is you get 9 units from the main scale. That means 9 millimeters divided by 10 vernier scale divisions. Then you get a vernier unit. That means vernier unit equals size of a main scale division multiplied by some number of main scale divisions divided by some number of vernier scale divisions. Now the size of a vernier scale division is 0.1 millimeters, right? Now the size of a vernier scale division is, 0.9 millimeters, right? It is 0.9 millimeters. So you place this 0 here, 0.9, that means 1 in the vernier scale. 1 in the vernier scale means 0.9 millimeters. 2, 3, this is 0.9 into 2, 0.9 into 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. Okay, so now how would we create what is the mechanism of this instrument? See, the gap between this 1 and 1, it is 0.1 millimeters. Gap between this 2 and 2, it is 0.2 millimeters. Gap between this 3 and 3, it is 0.3 millimeters. Why? It is 1 millimeter, 2 millimeter, 3 millimeter. It is 0.9 millimeter, 0.9 millimeter, 0.9 millimeter. So the gap is 0.3 millimeters. Then 0.4 millimeters, 0.5 millimeters, 0.6 millimeters, 0.7 millimeters, 0.8 millimeters, like that. Okay, like that. Now, to place something, if you push this vernier scale in this direction, if you see something like this, main scale 0, 1, 2, 3, 4, to measure something, you push the vernier scale in that direction. As a result, if this one falls above this one, if this one falls above this one, what is the meaning of that? If this one falls above this one, that means I have pushed this 0.1 millimeter, right? I have pushed this 0.1 millimeter, clear? That means if I push this by 0.1 millimeters, this one will create a straight line with this one, right? This one will create a straight line with this one, clear? So this is the smallest measurement I can measure using this mechanism, which is 0.1 millimeters, which is 0.1 millimeters that I can get by, that is the least count actually. That is the least count that I can get by size of a main scale division 1 millimeter minus the size of a vernier scale division 0.9 millimeters, which gives me 0.1 millimeters, which gives me 0.1 millimeters. That means size of a main scale division minus the size of a vernier scale division. Clear? That means size of a main scale division minus, how do we derive the size of a vernier scale division? Using this, right? How do we derive the size of a vernier scale division? Using this. Nm, capital M, divided by Nv. Nm, capital M, divided by Nv, which means M 1 minus Nm over Nv. So in this scenario, size of a main scale division was 1 millimeter. Size of a main scale division was 1 millimeter. 1 minus, I chose 9 units. I chose 9 units from the main scale and divided it among 10 units in the vernier scale. Okay. This gives me that 0.1 millimeters. This gives me that 0.1 millimeters. Clear? Okay. This gives me that 0.1 millimeters. That's how we derive things. Okay. Clear? That's how we derive things. Clear? You get main scale 1 millimeter, 1, size, number of main scale divisions 9, number of vernier scale divisions is 10, number of main scale divisions is 9, number of vernier scale divisions is 10. You solve this, you get 0.1 millimeters. That's how we derive the least count. Okay. That's how we derive the least count of a vernier scale. After that, reading things is the way I explain things. Okay. Reading things would be similar. Did you understand everything? Did you understand everything? That's how we get the least count of a vernier scale. Clear? That's how we get the reading of a vernier, get the least count of a vernier scale. Okay. So, any other questions, guys? Any other? Any questions? Anyone? And any other problems you are facing these days besides getting results recently? Least count of the main scale you can directly read. Okay. When you see the main scale, you can see it's either 1 millimeter divisions, either 0.5 millimeter divisions, like that you can see. Okay. Like that you can see whether they are 1 millimeter divisions or 0.1 millimeter, 0.5 millimeter divisions, that you can see. Okay. So, oh, you have a team for the match. Okay. There's a Google form. We'll provide that again in the group. Definitely join the community. We have provided all the information there. So it's about results and the match, not about the measuring instrument. See, where your focus is at? Isn't essential to use only the meter ruler for being the... Yeah, to measure those gap between the dots when using the spherometer, we use the meter ruler. Okay, we use the meter ruler. But if they ask, suggest a better method, yes, you can use the vernier caliper. But what you write is the meter ruler. Okay, what you write is the meter ruler. Clear? Extended vernier calipers, yes, I explained in the class, but usually you won't get questions from extended vernier calipers. Okay, but the usage is same. Okay, clear? Can some tips on studying? I mean, I always talk about this in the main class. You need me to talk about that in the practical class too, on how to study. How to study is study. Okay, just I mean, I have mentioned this. Just come up with a small schedule. These days, I know you guys can't work for 10-15 hours continuously. You are just having your free time, the last free time in your life. So yes, work 2 hours, play games for 1 hour, again 2 hours work, maybe play games for 1 hour, again maybe sleep for 1 hour, again work for 3 hours, play game for 2 hours. Like that, create a schedule where you have fun and learn both. Okay, that works. Yes, they ask you to name the parts of these measuring instruments, but I mean only in the first few term tests. After that, they may not, but it's good to remember. Okay. Now it's about the food and the cricket match. Anything else? Maximum length can be measured by each instrument. A good question. I have talked about this in the class. The vernier caliper is like 15 centimeters, 15 to 20 centimeters. It has like 15 to 20 centimeters. Like most probably it would stop at 15. Okay. Most probably it would stop at 15. Clear? It would stop around 15. See, 15 centimeters. Yes, there's quite a bit more than that, but it would stop at 18 centimeters, somewhere like this. Spherometer, the main scale, it is like 1 centimeter above and 1 centimeter below here. This is 1 centimeter, that means 10 millimeters up, 10 millimeters down. But I have seen some spherometers that can go up to like 1.5 centimeters up, 1.5 centimeters down. Okay, there are instruments with that range. Okay, there are instruments with that range. Then the micrometer screw gauge, we'll see. This is 1 millimeter. 10 means 1 millimeter. 10 millimeters means 1 centimeter. Sorry, 10 millimeters means 1 centimeter. I can see 15. Then I can see around 20. See, 20 millimeter line I can see. 20 millimeter line I can see. So I can go up to like, see, this is the maximum looks like. So 25 millimeters, which means 2.5 centimeters. Somewhere like 2.5 centimeters. Clear? The maximum distance of that instrument is somewhere like 2.5 centimeters. Then talking about the traveling microscope. Talking about the traveling microscope, see, there's like 20 something centimeters here. See, there's like 20 something centimeters here. 22. So close to 20. So, but see, I can't move this until 22. See, this is my maximum. See, this is my maximum. I can't move this further. Okay, this is my maximum. So although it shows 22, I can go until like 19 or 18. I can go until here. So it's going to be close to 20 centimeters. It's going to be close to 20 centimeters. Vertically, it's a bit lower. Okay, vertically I can see it's like 15. Okay, vertically it's like 15. Horizontally it at least shows like 20, but vertically it's like 15. Okay, clear? Vertical, it's like 15. Clear? So these are the ranges of these instruments. Any other questions? Is it okay to have 6 players in a team? Yes, come with 6 players, we'll give you another player. No big issue there. Anything else like away from like match and foot? Which measuring instrument can be used to measure the diameter of a thin wire? The ideal instrument would be micrometer screw gauge. Okay. The ideal instrument would be the micrometer screw gauge. Yes, you can definitely get a if you work properly. Don't worry if you don't have enough team people for the team, just fill with whatever the number you have. We'll fill the remaining part. Can we join individually in cricket? Yes, come individually, we'll find your team. Okay, so like M over NV equation, how it is derived. So here, take this. In many vernier instruments, we choose NM such that it is equal to NV minus 1. See here also 10 and 9. So if we choose NM such that it is smaller than 1 unit smaller than NV, what I'm going to get is M 1 minus NV minus 1 over NV. Okay. 1 minus NV minus 1 over NV. Okay. So here M NV, when I solve this, NV, here NV minus NV minus minus plus 1. Then NV cancels out, I get M over NV. I get M over NV. Size of a main scale division divided by the size of a vernier scale division. So in this case, in my example, size of a main scale division is 1 millimeter. Size of a vernier scale, number of vernier scale divisions is 10. Again gives me 0.1 millimeters. Again gives me 0.1 millimeters. So it works when NM is NV minus 1. Okay, number of main scale divisions is 1 unit lower than the number of vernier scale divisions. Okay, then only this equation works. Clear? Then only this equation works. Spherometer equation, I repeat, there were some questions, you don't have to worry about that. Get the value of H, get the value of A, okay, get the value of H, get the value of A, then put things into the equation. That's all. Clear? Put things into the equation. So are you guys talking like Hindi? Yes, you can measure the both internal and external diameter of a tube, of a capillary tube using the traveling microscope. Yes. Double pendulum theory means the Barton's pendulum, right? Yes, yes, we do that. New generation language apparently. Yeah, I have to learn this stuff. Can we bring players other than the people in the class? We'll let you know. What is the grand prize for winning team? You're gonna get an A for physics. Cool then. Cool. So then I think like we can wind up the session, right? We can wind up the session. Hope you guys learned a lot. Oh, about biomedical engineering. I'm gonna anyways talk about this engineering field specifically. I'll try to bring people from my department. Our Island First Tarusha did biomedical. I'll let them talk about these fields. We'll start something like that, a field familiarization program so that you can learn about each these fields. At the end of the day, the first thing you should do is get an A for all 3 subjects. Otherwise, you won't be able to select. But yes, I mean, it would be interesting to know, right? So we'll do something like that. We are doing English medium classes on Tuesday and the Sinhala medium class on Monday, okay? Yeah, it's not suitable for a liquid column. The traveling microscope is suitable for liquid column. Yes, we'll be doing multiple practical programs, practical workshops. Some practicals will be repeated again when it is close to exams. Practical seminars would be done. Things would happen again and again. A lot of kind of stuff would happen, but you have to join everything, okay? What is my O-level result, I mean? Assume. I mean, I'm at top 3 of the batch of University of Monato, so assume my O-level results. Oh, join your team. We'll see. So, I mean, there was one more question. I mean, why the rust in the depth probe? Why the rust in the depth probe won't affect? Why the rust in the depth probe won't affect the? Sorry, why the rust on the external jaws won't affect the depth probe? Why? What is the reason? Rust in the external jaws are here. It shows you a value. So you can't place an object here. Now there's rust here. Assume that there's rust here. So you can't place an object here. So it shows a value, but there's no object here. But see, the depth probe moves. See, depth probe moves with the reading. So depth probe have no error. With this reading, depth probe moves. So see, here I can measure a depth. Here I can measure a depth. See, I can measure a depth equal to this value. Equal to this value. Clear? I can measure a depth equal to this value. But when there is rust here, I can't place anything in between the external jaws, but there's a reading. So when there's no object, there's a reading. But it's not the case here. There's a depth and there's a reading. There's no issue when there's a depth, when there's a reading, there's no issue. But when there's a reading, when I can't place anything in between, when there is rust, that's an error, okay? That's an error. That's why the issues on the depth probe and the like other stuff won't affect the, I mean, issues on the external jaws won't affect the depth probe. Issues on the external depth probe won't affect the depth probe. Issues on the internal jaws won't affect the depth probe. Issues on the internal jaws won't affect the external jaws. These are independent. But if there's an issue on the scale, if there's some kind of a difference in the scale, if the scale is marked wrong, if this scale is marked wrong, it will affect this, this, and this all, okay? If the scale is marked wrong, it would affect all, okay? So everyone, thank you for joining for today's session. Hope it was useful for everyone, okay? And keep joining the sessions. We are going to cover everything properly. There will be starting vectors next week. That means mechanics. We'll be starting, we'll be doing more practical sessions like this, and the express class would start too. You have to join that express class too. You would find it very interesting to finish things fast. Try to join that, and weekly papers will also start. So there's a lot of benefits. There's a lot of trouble, I know, but at the end of the day, you're going to get good results than anyone else. That's our target. So thank you for joining today.
Game